Hi friends, welcome to this training RHCSA on RHEL 8. This is next session brought to you by SkillPedia.co, the website for learners and trainers to teach technology. You have different courses here like on cloud computing, databases, Unix, core technologies, DevOps and others. This is session 7 on RHCSA series. In the previous session what we learned was virtualization with KVM. We learned how to create virtual machines, how to install Linux, how to create virtual machine based on KVM virtualization from command line with PXE boot, with remote installation and local installation. The session 7 is about virtual networking for virtual machines. We are on part 2 as we've been talking about. This is part 2 and session on virtualization with KVM done. This is the current session 7, configuring virtual networking. Coming after this session will be automated installation options and then administration with SSH, that is secure shell, and SCP secure copy, and then some command line tools. Virtual network switches, what these switches are. The libvirt uses concept of virtual network switch. This is a simple software construction on a host server that your virtual machine plug in to and direct their traffic through. On a Linux host server, the virtual network switch shows up as a network interface. So you can see that in this setup, this is a virtual network switch example. This is a host machine, host server, and the virtual machine plugs into this virtual switch. The default virtual network switch created when libvirt daemon, that is libvirtd, first installed and started, shows up as virbr0, virtual bridge 0, and you can use ifconfig that to show this virtual switch. So if we try ifconfig virbr0, we can see the switch, or we can also use IP address show virbr0 or simply ifconfig-a or IP address show. A lot of options: ifconfig bridge name, or IP address show bridge name, or IP address show, or simply IP space a. Let's take a look and let's see these commands. This is our command line CLI, and I can show you using these commands all this. Like if I type ifconfig virbr0 will show that switch. This is our bridge and the IP address of the bridge. Same can be shown by using IP space a. That will also, oh sorry, I missed the a. So virbr0 is visible here, and this will show up using that command also. Another is ifconfig address, IP address show will also show the virtual bridge 0, virbr0, and you see the IP address of this bridge. So this way you can check the existing virtual bridge which you have configured, which is actually automatically configured when you start libvirt daemon for the first time. By default, the virtual switch operate in NAT mode, which stands for network address translation, using IP masquerading. What does it mean? It means the virtual machines which is plugged into the network switch, whatever IP address these machines have, their IP address will be translated, and will not be visible to the outside world. So outside world machine will see the internet based, or the outside world machine will see the IP address of the host machine, that is 10.10.10.10.10.190. So any traffic coming from internet will see only 10.10.10.190 in this particular example. They will never be able to reach to this 192.168.122.210 or 220. NAT is applied between the host network switch and the virtual network switch. That is where the NAT is actually applied. So any guest connected through it use the host IP address for communication to the outside world, whereas computers external to the host can't initiate communication to the guest inside when the virtual network switch is operating in NAT mode. IP tables consideration. The NAT is set up using IP table rules. Be careful if you change these while virtual switch is running. If something goes wrong with the IP rules, your virtual machine may stop communicating properly. DHCP and DNS server. Each virtual network switch can be given a range of IP addresses to be provided to guests through DHCP. You don't need to configure a dedicated DHCP server for that, because libvirt or library or virtualization library, we will call that virtualization library. libvirt or virtualization library will use a program called DNS mask. So this DNS mask is used to provide IP addresses on the virtual machines on lease basis. An instance of DNS mask is automatically configured and started by libvirt for each virtual network switch needing it. So this is a virtualization host server, virtual network switch, and DNS and DHCP server is provided by DNS mask, and they will also give you the DHCP range, which actually is in the range which is used to give the IP address to the virtual machines which may need the IP addresses on lease. Virtual network switch routing types. Virtual network switch can operate in two other modes instead of NAT, in addition to NAT. One is routed mode and another is isolated mode. We'll understand both these modes in detail. Routed mode. With routed mode, virtual switch is connected to the physical host LAN, passing guests network traffic back and forth without using NAT, which actually means you will be able to connect to the outside world, and outside world will be able to reach to your machine. That is, routing of the traffic will happen properly. So the virtual network switch sees the IP address in each packet, using that information when deciding what to do. All virtual machines are in a subnet routed through virtual switch. This on its own is not sufficient, because no other host on the physical network know that this subnet exists or how to reach this subnet. So it is thus necessary to configure routes on a physical network, which is by means of static route. So we need to configure a static route for this purpose. So this is how routed network or routed mode of virtual network works, virtual switch works. We have virtual switch in routed mode. Here this is configured in routed mode. The virtual machines are using 10.10.10.100, 10.10.101. These are the IP address of the virtual machines. Host machine have 10.10.10.1 IP address, and outside machine will be able to route the traffic directly to this machine, whatever address they have. So this machine 10.10.10.100 or 10.10.101, these IP addresses are reachable from the outside network or outside machine, which is actually means I'm talking about the internet. So internet can reach to these machines if the virtual switch is configured in routed mode. Then third mode is, beside NAT and routed, isolated mode. Isolated basically means there is no connection to the outside or network. So it is no communication between the outside world and the network switch, which means, but the machine in themselves, they will be able to communicate with each other. In this mode, Guests connected to the virtual switch can communicate with each other and with the host. However, the traffic will not pass outside the host, nor can they receive traffic from outside the host. Typical scenario will be when you are configuring a cluster, when you are configuring a demilitarized zone, when you are configuring an isolated network. This is the perfect use case. The use of DNS mask in this mode is possible, and in fact it is needed, since it is used to answer DHCP request by the virtual machines. However, even if this network is isolated from any physical network, DNS names are still resolved, which means that it will be a typical situation. You may get into a situation where DNS are resolved but guests are unable to ping. That is isolated network or isolated mode of virtual switch. What is the default configuration? These are three modes we discussed. When you install and start libvirt and the DNS mask service is started, what is the default configuration? When the libvirt daemon is first installed on a server, it comes with an initial network switch configuration, and this switch is in a NAT mode and is used by installed guest for communication to the outside world. So physical Ethernet port ETS0, for example, the machine will be able to reach to that, and VIR-BR0, that is DNS and DHCP server DNS mask where it is running, and the VIR-BR0, the interface which we are seeing, will be used. Virtual network switch working in NAT mode, guest machines will be able to reach to the outside world will not be able to reach to these machines, and DNS and DHCP servers are configured and running in this mode. So this is default network configuration, NAT based. The libvirt daemon puts this configuration into effect when it starts up. So if you have the libvirt daemon set up to start automatically on each boot, it will always be present. That means the NAT based NAT mode switch is already available, always available, the default configuration. If the libvirt daemon is started manually, then this is when the default network switch will become available on the host. That means if libvirt daemon by default is not started, so this virtual network VIR-BR0 will not be visible, but when you start it, it will be visible. Restricting virtual network traffic to a specific interface. A virtual network can be connected to a physical network. Its traffic might be restricted to use a specific interface. For example, on a system with ETS0 or 1 or 2, one can limit the virtual network to use ETS0 only, even if you have 3 interface cards. However, this only makes sense in case of a routed mode and NAT modes. The restriction can be because ultimately isolated mode does not use it. They don't need it. The restriction can be defined in XML file, the configuration file, using the directive dev is equal to followed by the value which we want in virt manager, or in virt manager when we're creating a new virtual network. We are going to create a virtual network, and I'll show you the demonstration also immediately after this brief discussion. Examples of common scenarios. Now, routed mode use case. Suppose there is a network where a node or bunch of nodes needs to be in special subnet or subnetwork for, let's say, security regions. This is called DMZ or demilitarized zone, where the machines, virtual machines, will be able to talk to each other, and this host machine, physical machine, will be able to connect through the firewall with wide area network or internet through the demilitarized zone. So this area is restricted, and the routed traffic will be routed through one physical switch or one switch to the internet. So we have one security gate, or we can have one security entry through firewall setup, where the traffic from outside world will be able to reach to the guest machines using the routed mode. What is the demilitarized zone or DMZ? Host in DMZ or demilitarized zone provide services both to LAN host and wide area networks. Therefore, they need to be accessible by other computers on the intranet, that is local to them, that is inside the subnet, and also by computers in the internet. Since this, it would not be secure to have them on local area network because attacker could access LAN after a successful attack. They are in a special subnet. In addition, it is obvious that they can't be into NAT or isolated mode. Another scenario for routed mode is this particular use case, very good use case. Consider a virtual server hosting company. Each host will have two physical network connections. One is for general management, that is accounting and management, and the other is for virtual machines to use. That's where the machines are interacting with each other. Each virtual machine has its own public IP address also, means this machine is reachable from the outside world. Hosts, however, use private IPs. Because the virtual machine management is allowed to company administrators only. So in this case, the machines will interact with each other using isolated mode, and the outside world will reach to these machines using routed mode. So this is a typical use case where we can have two different type of networks for the accessibility to the outside world from the virtual machine. Another scenario for routed mode, again, it is obvious virtual networks which can't operate neither NAT nor isolated mode. And special case, this is another example where host has public IP and virtual machines have static IPs. But one can't use bridged network since provider accept only packets from the MAC address of the host. And this is a whole scenario of this in this particular example. The host acts as a router, letting the outside world communicate with the virtual machine by IP address. For example, 192.168.1.10 and 11. In this case, these are the IP addresses of these virtual machines. And this is a routed mode scenario, another scenario for a routed network. Use of NAT mode. When do we need NAT mode? This is the default mode and require no additional configuration at all. This can be used anywhere where there is no need for being seen on the network. Meaning you should be able to download packages, upgrades on your system, but you don't want to be seen or visible for the outside world. For instance, a web developer who optimizes web pages for different operating systems and web browsers, or any other developer who need to try things out in different configuration environments or operating systems. Use of isolated mode. An example where this mode would be useful is running simulations in security field, where the spread of malware is being watched. The virtual machines can communicate with each other, but since they are cut off from the physical network, no real damage can be done because they cannot reach to the machine. So they can, the machine can reach them, but they cannot reach the machine. How to start? In Virt Manager, by clicking Start Network or using virsh net start. Let me show you both. This is my environment, so I can click on this, go to the details where I'll see my virtual network, and here I can see start and stop button. So this is the start. The moment you select the network, you click on the start button and it will start. And right now it is already started, it is already active. And second, the command is virsh net start. That is from the command line we can see that. Virsh net start and the hyphen network and network name. So these can be used to start the network. So this way we can start. This command takes mandatory argument the network name. Of course, I am talking about virsh net start. When starting a virtual network, libvirt will automatically set IP tables and DNS mask. However, transient networks are created and started at once. Stopping, Stopping virtual network can be done by clicking on the properties button in the virtual network manager or by net destroy. If it is in transient network being stopped, it is also removed with this command. The command line uses for virtual networks: virsh netlist. Let's see that, and let's open that interface also. Virsh netlist, net destroy, these are all virsh specific commands. Let's open the network and see these commands. Virsh net-list will show me the default or active network. Virsh net stop, net destroy will destroy that network switch, and then virsh net undefined will remove the configuration. So these are the commands which we can use for managing the network, virtual network, through virsh command. Virsh netlist lists the virtual network libvirt is aware of, along with some basic status and auto start flag information. Used without parameters, it shows up active virtual network only, and this is what I showed. If you use -- all, it will show all. If you just want say inactive, you can use -- inactive. Net start an inactive previously defined network. So virsh net start network name. Of course, you have to specify the network name -- network. Virsh net destroy, stop the active network and deallocate all resources used by it. For example, stopping appropriate DNS mask process, releasing the bridge. Virtual network being stopped can be persistent or transient. Virsh net destroy -- network and the network identifier. This is how the command is used. Net undefined, remove an inactive persistent virtual network from libvirt configuration, that is net undefined network and the identifier. Command line uses continued net auto start. If you use virsh net auto start, it will mark or unmark automatic startup of a persistent virtual network. Networks with the auto start flag enabled are started whenever libvirt daemon starts. To disable auto start, we can use -- disable, like virsh net auto start -- disable, followed by network -- network and network identifier. Net name, return the network name corresponding to the given UUID. So you have to provide the network UUID -- network UUID. Net UUID will return the UUID corresponding to the given network name. Quite self-explanatory commands. Virsh net UUID. Net dump XML. This is what I want to see. Dump XML will output the XML configuration of a virtual network. Let's use virsh dump XML. Virsh net dump XML and the default. This will show my default XML file which is configured for this network, that is dump XML. And let's try this another command, net UUID. Virsh net UUID default. This will give me the default UUID. If you want to name, you can use virsh net name. You have to provide the UUID, and this will show you the name of the network. So I demonstrated these two commands as well. So these are some of the commands which are used to manage the virtual networks. That's all for this session. Let's have the demonstration now. Try some practice and some commands, and for this we have this lab assignment, virtual networks, networking on virtual machines. Let's do this, some examples from this lab. And mind it, this lab is available as a blog on the website theskillpedia.co, and therefore it is worth trying. I'm just opening it so that I can quickly show you. So first thing is, on the properties, host properties dialog box, right click on the host menu and click on properties. This is basically, we are referring to this interface. So identify these interfaces. So if we have a virtual network manager running from the GUI, this is talking about that part. So let me show you this. So on this is saying right click on that and go to details, and here you see this network switch. Alright, go to the properties and network, virtual networks is visible here. You see, I'm talking about by default it will show you overview. I click on virtual network and then you see the default network. Now start the virtual network assistant. In the bottom left corner of the dialog, there is a small button with plus sign. Click on it. This is what I'm referring to. And here you specify to start a new virtual network. This is a wizard will start. Create a virtual network wizard, and you specify the name. You can see the XML file here. You specify the details. So, and this is what we are going to start the wizard. So virtual network start Wilson. So we'll follow the lab and we'll exactly do the way lab is given, and lab NAT 172. This is a wizard we are creating, NAT based, and the IP address. Yes, I'm going to specify IP address. There's 10 dot. I'm going to specify this range only because I'm specifying 172. So I'm using this particular details. So let me type 172. 172.16.0.0, and now this is I want to define a size size of 12, though I can specify 24. That's okay for me. 12 is good enough, good size. And enable DHCP server, and this same thing you can see in the lab assignment as well. So it is matching. You see, I use the 24, or you can specify this range, and then click on finish. It will create that, and the network is created. Error creating virtual network. The range is too large, so let's make it a little less. It says range 12 is too big, so let's make it 24. That's good. That will give you less size. So let's create this. Now it is created. So 172 network is created, and we are done this with this part. Now this is a second example. This is one more example here. Connect to the outside network. We can see that also here by clicking on this and go to properties. IPv4 configuration. Yes, this is okay. Let's create the next one. Create network wizard. This is the next one. Alright, so let's create another one with different mode. This time we are creating in different mode. So give me a second. Yeah, net part is done. Yes, perfect. Let's create another one, and this time we are using route 192. We are creating another one. Another network is being created. This is the machine setup. We'll configure this and we'll show you isolated and the same machine. You can specify whatever IP address, like I'm using a routed mode or 192 or that isolated mode. So now onward I can simply demonstrate NAT or what, routed or isolated. Let's say routed, where the traffic will be forwarded to, any physical device or a specific physical device. Let me use any physical device. IP address, you can specify the IP address. Let's say I'm specifying 192.168. And let me use 2 IP address of this range, and then finish. We'll create it and then network routing 92. And now let's create a isolated also, isolated 10 series, and this time I'm using 10 series IP address. Mode is isolated. IPv4 address, this time I'm using series 10, 10.10.0.24, and I configure this IP address. So I have 3 different virtual network switches configured. Now we need to make the machine use these network switches. Let's go to the machines. Now on the machine I'm using test1 and test2, both machines use this. Okay, virtual machines, details. Let me go to the details part. Right click on it. 1 second. View details. On view details, you go to view, you see details and console and snapshot. Go to the network here. So network part, network with the network interface part card, you can see that here. So this is the default NAD mode. Let's add another network interface card which is under networking. We'll find out here, and let's add. So adding a new hardware. Which mode you want? I configured routed or NAT. I'm going to use isolated mode. Isolated mode, added, finished. And let's start the machine now. Show the details, start the machine. Now the machine will start using another interface. Let's same thing we do on this machine also. Open this machine, view details, add hardware, select network, select same mode, that is isolated mode, and finish. Network card added. Now start the machine. Machine is running. Now we have to go inside the machine and configure the networking. Alright, click on the first machine, click on open. This will open the machine. This is my first machine. Now I already have that network interface card added, and I can connect to that IP address, and will show you the configuration of this machine. Let me open the terminal. IP space A. You see the IP address is visible, which should be of series 10.10. And I don't see that IP address here right now. This is my existing ENP0S0. ENP7S0 is the one which I added. So because this is second interface card, first is working in NAT mode, this is working in NAT mode, which is getting the IP address from that machine 192.168 series, and this is the IP address. This is the internet card which I just added. So we need to configure this. NMTUI can be used to configure this. Edit a connection, and let's add that connection. I don't see that connection, so I need to add it. No problem. Activate a connection. I don't see that. No problem. So what we will do is we'll configure it. In fact, let's do it from here. Settings, network, and this is the ENP0S8. So I don't see that card. What I'll do is I'll add it manually. IP A and ENP7S0 and ENP1S0. So I'm going to use ENP7S0 because this is my card which I added. So NMTUI, edit a connection. Let me add Ethernet connection, and I specify here ENP7S0, and the device is ENP7S0. and now I can take the IP address from the DHCP server because that is already configured, and let's go back and quit. Now if down, ENP7 S0, and if up, ENP7 S0, and let's use IP space A to check the IP address, and we got the IP address from the DHCP server, which is 10.10.10.0.170. Now let's repeat the same process on our second machine, because we want the machine should be able to connect with each other. So this is my machine. Click on view, click on console, login as root, and we configure the same here, nmtui. Let's first verify IP space A. You see ENP0S7 here also, and in fact it is automatically activated, and I can see the IP address 10.10.0.163. Let's try to ping the other machine. Ping 10.10.0.170 was the IP address of that machine, and I can see that I'm able to connect. This machine have IP address 163. Let's see if I can ping this machine from that second machine or not. And ping 10.10.0.163, and I'm able to reach. So you see, I have configured isolated network on both my machines, and I'm able to reach each other. Networking is successfully configured on both the machines. Net was already configured. Default network creation, we created two network. One was routed, second was isolated, and we were able to configure networking in the machine successfully, and we were able to ping each other. That's all for this session. I hope you enjoyed it. Thank you very much for